Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology subject. So in this already, so far we have covered friction and wear and corrosion and lubrication topics. So now in this session, in previous session already we have studied, we have learned model paper 1 questions. In this session I want to discuss about model paper 2 questions that related to this corrosion topic. So in this, as asked a question, differentiate between cathodic and anodic protection. So already we have seen the detailed cathodic and anodic protection methods. So again here, so other methods also we have studied. Many methods are there. So for protecting corrosion methods. So in this, so here specifically asked cathodic and differentiate between cathodic and anodic protection. So what is the main difference between these two? So cathodic protection and anodic protection are methods used to prevent the corrosion of metals. Already you know, they operate on different principles and applied in different contexts. But here one by one we will see the difference. The cathodic protection, what is the principle? One is cathodic protection works by making the metal structure and cathode of an electrochemical cell. So this is achieved by either applying a direct current from an external power source or using a sacrificial anode made of a more easily corroded metal. So that is the main principle of cathodic protection. The types in this, two types are there. One is sacrificial anode method, another one is impressed current method. So the sacrificial anode method uses metals like zinc, magnesium or aluminum as anodes, which corroded instead of the protected metal. The impressed current method uses an external power source to provide a continuous DC current to the metal structure, so making it a cathode. So now the applications are commonly used for underground pipelines, ships, offshore platforms, and storage tanks. The advantages are effective for large structures, provides long-term protection, can be monitored and adjusted. Disadvantages can be costly, especially the impressed current method, requires maintenance and monitoring. The sacrificial anodes need to be replaced periodically. So this is the disadvantage of this sacrificial method. The anodes frequently have to replace. And one more thing is it is very costly. So the maintenance and monitoring cost also very high. Anodic protection. The principle is anodic protection works by making the metal structure the anode of an electrochemical cell. This is done by applying a controlled anodic current, which causes the formation of a passive oxide layer on the metal surface, protecting it from corrosion. The mechanism involves the use of an external power source to apply a small anodic current, which maintains the metal in a passive state. Next applications are suitable for metals that form a passive oxide layer, such as stainless steel and certain alloys. often used in chemical processing equipment, storage tanks for aggressive chemicals, and other industrial applications. The advantages are highly effective for specific metals and environments, can provide very long-term protection, reduces the rate of corrosion significantly. The disadvantages are one is not suitable for all metals and requires precise control of anodic current. And one more thing is it can be complex and costly to implement and maintain. So only this is suitable for stainless steel and certain alloys and then other industrial applications. Cathodic protection. So in this makes the metal the cathode often used with sacrificial anodes or impressed current systems suitable for large structures and provides long-term protection. The anodic protection makes the metal the anode forms a passive oxide ion layer suitable for specific metals and environments and requires precise control and monitoring. Each method has its specific applications and advantages, and the choice between them depends on the type of metal, the environment, and the specific requirements of the structure being protected. Next, evaluating corrosion involves various methods to understand the extent and the type and rate of corrosion. These methods help in designing better corrosion prevention strategies and ensuring the integrity of structures. Next, visual inspection. The simplest and most straightforward method involves visually examining the surface of the material for signs of corrosion such as rust, pitting, or discoloration. The applications are used for routine inspections of pipelines, storage tanks, and other structures. So, evaluating corrosion involves different methods to understand this, understand the extent and type and rate of corrosion. So, advantage of this visual inspection is quick, non-destructive, and inexpensive. Disadvantages: subjective and may not detect subsurface corrosion. So this is different evaluation methods of corrosion. One is visual inspection, another one is weight loss method. So in this, it involves exposing a metal specimen to a corrosive environment for a set period. Then measuring the weight loss to determine the corrosion rate. The applications common in laboratory testing and research to evaluate corrosion resistance of materials. The advantages: direct measurement of corrosion rate. Disadvantages are time consuming and destructive to the specimen. Next method is electrochemical methods. So in this, potentiodynamic polarization. So what is this potentiodynamic polarization? It measures the current response of a metal to a varying applied voltage to determine corrosion potential and corrosion rate. The applications of this potential dynamic polarization is used to study the corrosion behavior of metals in different environments. Advantage is provides detailed confirmation on corrosion mechanisms. So the major disadvantage is requires specialized equipment and expertise. So in this required specialized equipment and also required expertise. Skilled persons are required. Next, electrochemical impedance spectroscopy. So that is you can denote it with EIS. So it measures the impedance of a metal surface over a range of frequencies to evaluate corrosion resistance. The application is used in research and quality control to study protective coatings and inhibitors. So the advantage is non-destructive and can provide information on protective coatings. Disadvantages: complex data analysis and requires specialized equipment. In this also, the data analysis is very complicated and also requires specialized equipment. Next, surface analysis techniques. So, scanning electron microscopy, SCM. It provides high resolution images of the metal surface to examine the morphology of corrosion products. The applications are used in failure analysis and research to understand corrosion mechanisms. The advantages are high resolution and detailed surface analysis. So you will get higher resolution and detailed surface analysis. So disadvantages are it is too expensive and requires sample preparation. So sample preparation is also required. Next, energy dispersive X-ray spectroscopy. So the main aim of this X-ray spectroscopy is coupled with SCM, EDS analyzes the elemental composition of corrosion products. The applications are identifies elements involved in corrosion process. The advantages are provides elemental composition and distribution. So the main disadvantages is limited to surface analysis only. Next, non-destructive testing, NDT. So one is ultrasonic testing. In this, uses high frequency sound waves to detect internal flaws and measure material thickness. So applications are common in pipeline inspection and structural health monitoring. This type of method is useful for monitoring the structural health condition. Similarly, pipeline inspection. So advantages: non-destructive, can detect subsurface defects. Disadvantages are requires trained operators and may be less effective on a rough surface. Radiography, X-ray and gamma rays. So the main description is uses X-rays or gamma rays to create images of the internal structure of a component, revealing corrosion and other defects. The applications are used in critical infrastructure inspection and infrastructure inspection like bridges, aircraft and weather vessels. The advantages are can detect internal corrosion and defects. The main disadvantage is expensive, requires a safety precautions and interpretation of results needs expertise. So for an interpretation of results needs more expertise and also required more safety precautions. So why? Because we are using radio X-rays and gamma rays. So very powerful rays are using to create images of the internal structure of a component. Chemical analysis. Atomic absorption spectroscopy. In this, analyzes the concentration of metal ions in a solution, indicating the extent of corrosion. The applications are used in water treatment and monitoring of industrial process. The advantage is sensitive and specific. Disadvantages requires sample preparation, is destructive to the sample. So next, inductively coupled plasma spectroscopy. This one also similar to AIS, but can analyze multiple elements simultaneously. So use it for a comprehensive analysis of corrosion products and solutions. The advantages are high sensitivity and multi-element detection. So these are the advantages of this coupled plasma, inductively coupled plasma spectroscopy. So disadvantage is expensive and requires specialized equipments. This is the main drawback of this method. Next, accelerated corrosion testing. So, salt spray test. So in this, exposes a metal specimen to a salt spray, that is fog environment to accelerate corrosion and evaluate protective coatings. The applications are commonly used in automotive, aerospace, and marine industries. So the main advantage of this accelerated corrosion testing is to provide quick comparative results. The main disadvantage may not accurately represent real world conditions. The cyclic corrosion testing. So subjects to specimen to alternating cycles of wet and dry conditions to more closely simulate natural environments. The applications are used to evaluate the durability of coating and materials. So the main advantages of more realistic than continuous salt spray test and the disadvantages are more complex and time consuming. So next question is discuss the role of material selection in prevention of corrosion of components. So in this, material selection plays a critical role in the prevention of corrosion of components. So choosing the right materials can significantly enhance the lifespan of a component. So reduce maintenance cost and ensure uh, ensure safe and reliable operations. So intrinsic corrosion resistance. So you can see in this case stainless steels and aluminum alloys and titanium. So the one passive oxide layer protects the steel from further corrosion. Similarly, a protective oxide layer that guards against further oxidation develops a thin protective layer aluminum alloys. In the case of titanium, exhibits excellent resistance to a wide range of corrosion resistant environments due to its stable rare and toxic. Next, environmental compatibility. Aqueous environments and higher temperature environments, chemical exposure, and galvanic compatibility. The selecting materials with similar electrochemical potentials when designing multi-metal systems can minimize galvanic corrosion. So whenever the tantalum and ash alloy are chosen for their ability to resist aggressive chemicals, including strong acids. Next, mechanical properties and fabrication. So already you know the mechanical properties, ductility and strength. Materials that can withstand mechanical stresses without cracking are essential, as cracks and crevices can be initiation sites for corrosion. Ease of fabrication. Coatings and surface treatments. Protective coatings. Materials that can be easily coated are treated to enhance their corrosion resistance. For example, steel can be galvanized, zinc coated to protect against rust. Similarly, anodizing. Aluminum components are often anodized to thicken the natural oxide layer. So, in this case, improving the corrosion resistance and allowing for coloring. Cost effectiveness. Cost is always consideration by selection of slightly more expensive material that offers superior corrosion resistance. Can lead to significant savings in the long term by reducing maintenance. And you can reduce the downtime and replacement cost. Similarly, specific industry requirements, marine industry and oil and gas industry. So certain steels are preferred for their resistance to seawater corrosion. Incol and other nickel-based alloys are chosen for their resistance to sulfate stress crackling and other corrosive agents found in an oil and gas extraction. So these are the references I have taken for this question paper. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.